All right, as usual, we start the project. We select our repository. Many of you have sent repositories that got my, I accepted your invitation. Thank you very much. If I see anything is wrong with it, I do two things. Either I open up an issue in your repository, so if you see there is an issue, when I say issue, there's an issue tab. When you click on it, it tells you if there is an issue with your repository or any code that you have written or anything that you have. If you see there's an issue, please fix it, or I'm gonna send you an email if you have your email telling you that this is wrong or that is wrong. So if you received an email from me, please correct it, correct the problem, so I can actually go through your repositories and give you feedback. So we are in 345 and we are section NDD, and this is C-May 14th. Created. Hopefully this is the last time that I'm going to create something in class. I'm just doing it to remind you of the minor thing that you have to do. Always you have to go to the properties of the project and set the project to be C++ 17. I'll do 20, you can do 17. Apply an OK, and then you can start doing whatever you are doing. What do we need to do next? Let's open up what we have done last time. So let's reopen another one. One second. Oh, it's going to open. Okay, that's this Visual Studio is really buggy. I think we're good. Okay, this is better. Okay. Yeah, there's an update. Make sure you update your Visual Studio. Mine crashed so many times halfway through development, and keep saving your code because it didn't recover actually the code that I've written. I was ready to shout and go bananas, but yeah. So careful when you're actually coding. So that's that. Preparing Okay. So we talked about code segments. We mentioned we had different parts of memory, how things go when we are actually creating variables and code and functions, what each part goes to. Again, I'm opening this. If you have any questions about what we've talked about, stop me and ask the question. We talk about type defs. We said type defs are to create a type out of an already existing type. That type can be a complex type, or it could be a composite type, or just a long primitive type that you want to shorten the length of it, as we mentioned over there. We talked about command line arguments, and we said that when you're actually writing a program, the main that you're writing, can receive command line arguments from the execution command line. argc is the number of arguments on the line when you're issuing the command line, including the name of the executable. So it's always at least one. And then to the number of that one, you have arrays of pointers over here that one by one point to the values you're receiving. Then we talked about environment variables that are essentially all the variables that you have in the operating system. All the variables in the operating system, like path, the number of processors, username, home directory, everything that is set up in the operating system goes to the third argument, that is env. That environment variable was null terminated, unlike argv, that the number of C strings are in argc. env, you have to go up to a null pointer. As soon as you get to a null pointer, you stop right there. We talked about return statements, where the return statement value goes back to. It goes back to the operating system, and each operating system has its own environment variable for that. On Windows, it's %error11%. In Linux and Mac, it's $! So if you echo the value of these two right after the execution, the value that your program is returning is going to be over there. So that's important. Why is it important? If they write any kind of scripting language to run many different programs, and one of those programs are yours, the state of the program being ending is extremely important, and that's the message you are sending outside. So my program ended in this state, so they know if something goes right or wrong. That's how I check to see if your submissions are valid in Submitter. So when you actually compile your code, I'll get the environment variable that compiler sets after compiling your code. It's going to tell me if you have errors, warnings, and stuff like that. So I get the values like that in the Submitter program. And I don't know what stuff is over here. Oh, probably we're talking about global variables. Oh, static and static duration. Something that is extremely important is that statics with respect to static variables, they have the global lifetime, but they are only visible in their own scope. We said if you create what we call in C a global variable, which is essentially a file scope variable, that is a static variable too, even if you don't mention static. It will exist for the lifetime of your application, but it's only visible to the file that is created in. If you want to make it global, you have to extern it, okay? And that's that. That's what we talked about last time. Any questions, suggestions, and objections about the last session? All right. Add a new item as usual. CPP. We are not going to do this anymore. This is the last time that I'm actually creating the main thing here. From now on, you remember that you have no idea. The reason that I keep doing this is that when the assignment comes up, students come to me and say, my program doesn't compile. And 3 out of 10, I say, just go set the thing to C++17. And then it's going to work. Okay, so that's what I'm doing. So this is May 14th, OOP345NDD. Compile and run. All right, about the addendum. We talked about the addendum that I said it's not set properly, yada, yada, yada. Okay. So When I wanted to set it up, I found out that there is still problem in it. So I said, to heck with it. What I did, I put a PDF version of it inside the repository. So if you open up the repository, go to section D, you will see that in the repository in section D, there is an addendum PDF. If you open that one, that brings up the addendum for this semester. As soon as I get approval that this is okay, then I'm gonna post it on SYL, but for now, this is all the information you need to know about the subject. The assignments over here are 20% of the subject, right? So when you look at the assignments in the addendum over here, it says assignment number 1 is 3%, number 2 is 5%, okay? So I'm gonna take 1% out of these two and give it to your GitHub assignment. So it's gonna be 2.5% for that one and 4.5% for assignment number 2. And you're gonna have 1% for the GitHub setup. Okay, yes?
Sorry, do we need to submit our workshop 0?
No, that's the thing, is your workshop 0, that was for OOP345. I wanna force them to, the reason that I did have submission like that, I have to explain, IPC 144 doesn't use Matrix anymore. And they don't know how to use Visual Studio, they don't know how to use Matrix, they don't know what is Telnet. FTP parts are good because they don't know what FTP is anymore. I can start them with GitHub. But the problem is that I need them to submit something on Matrix so they learn. So as long as you get acceptance from me for your GitHub and you don't see any message coming up over there telling something's wrong, you got your mark. How do I know if you have done it right or not? This is how I do it. So every single person who does it, I'm gonna go over here and see 345 section NDD. These are the people that I accepted their stuff. So when the due date comes, I'm gonna go one by one over here, take a look at the README file and mark them. So as soon as I see your invitation, I accept your invitation, I bookmark it. If you have problem, I won't bookmark it, okay? Although the due date is Friday, right?
Yeah.
Yeah, so by Friday, please fix anything that you have. Remember, you need your, first of all, when you do the README file, make sure when you save it, it looks good. It means if you made any boo-boo, you see it's one straight line, fix it. I need your name, student number, Seneca email in the README, not in the profile, and section and subject. Because I have two different sections, I need to know which one you're in, and you're good to go. Then periodically, I'll jump into your GitHubs and see how active you are, and if everything is being done properly or not, or if you have any problem with your code, I'll give you feedback, okay? Again, you should live and breathe in your GitHub repository. Keep committing to it. Today, I had students from my last semester and a half ago and said that we are trying to get a job and we can't find a job. And I immediately said, okay, what's your name? And I Googled their name, their GitHub didn't come up. I said, didn't I tell you to create your GitHub and be active in it? When you submit your resume, the very first thing they do, they Google your name. When your GitHub repository comes up, like your LinkedIn account, like your YouTube, TikTok account, when your GitHub repository comes up and they Google your name, it's a huge green flag to hire this person because this person already knows how to collaborate. If somebody knows what is code versioning, that person is a coder, okay? So remember that. That's why I asked you to create your own private account. Don't use Seneca organization, so you're visible out there. That's why I asked you to put your real name in your profile, your proper emailing profile. So when you give your email in your resume, when they Google it, your GitHub account comes up, okay? And another thing that I want to tell you, don't leave public repositories, this is my code. They don't like it. They like to hire a person who understands what is intellectual property. If you leave everything open, but if you say my code is available in a private repository, I can make it accessible to you if you want. So you can review my code. They love that because they know you are willing to share your code with them, but you are not opening it to public, which means you respect intellectual property. Okay, you're not gonna steal their code and run away. Okay, so these are the things that is. But if you have some code that you have written it yourself, all by yourself, it doesn't belong to your assignment. Opening your assignment as public and offering it to someone is a red flag. They're not gonna hire you. This is my assignment in Seneca, and you make it available, that means I'm opening the private code to everyone. They don't like it. It means I plagiarize. So if you have a code that is fully your own and you're open sourcing it and putting it on the web, that's fantastic. But come up with your own. Little things that you do, write your own code. And believe me, you don't have to write GUI stuff to be nice. In the lab that you're coming when you're doing your quiz 0, the other class did it now. Quiz 0 is the one about OOP345 thingy that I told you that you're gonna do. And we're gonna go through the process to see how the quizzes are done. You'll see what I mean when I say write code for whatever you do at home. I like your computer. You have a baby version of mine. All right. Okay, so that's that. So now we know. Scopes are over. I'm just, let me actually, not a bad idea to actually go through it in here and see if there's any important stuff missing. Look at the title of the stuff and see if, and that's gonna take a while to come. For some reason at school, it takes 3 minutes for that thing to go. At home, it's like that. I have no idea why. I don't know why it's like that, but anyway. ArcCR we did, EM we did, static variables we have dealt with. Static, we didn't talk about static methods, right? Static methods, okay, we're gonna go through that today. Okay, let that thing come up. So, I'll leave it over here and hope that it's gonna come up one day. I think I need to create a local repo for this. Okay, let it load, let it load, let it load, okay. We talked about statics and we said static variables, they hold the lifetime of the application, but they're visible in their own scope. Then we said static variables are also file scope variables because they have the lifetime and they're visible in a file. They are kind of static too. But we have two more types of statics that we need to be cautious about. Number one, when you create a class, let's say class container I create, and the class container over here has some attribute, I don't know, integer, value, whatever value that it has. Now, I want to know how many containers I actually create in my I found a trick. So when it's rolling, if it rolls and doesn't come up, go on the URL and tap again, click again. I think it does send the request again and this one passes through. Just if you're at school and you keep seeing that it's, okay. So I could create a static variable inside a class. So I can have something like static size t, let's say, or static int cnt. Okay? So I can have a static variable inside a class, but we have to see what does that mean. When I create a static variable within a scope, we say that that scope holds the variable and it's alive in there. the problem we have over there, our scopes are unique. When you create a standalone function, it has its own scope and only its own scope. You don't have two different versions of that function. Problem with statics in class is that the scope of the class is the scope of the object, not the class. That makes the thing a little, wait a minute. So it's static to which? The answer is this. If you create a static variable inside a method, that's inside the method. But if you create a static variable inside a class, then other languages call that thing shared variable, which means or they call it class variable. What does it mean? It means when you do that, that static variable becomes a shared variable between all instances of the class. So if you have one static variable here, and then you have series of classes, series of objects of the same type of a class that you have, they all share the exact same one. Okay? So if I have 5 instances of container, they all have access to the static variable. So if the first one writes something in it, the second one can pick it up. It's a good place to pass messages between the same instances of the class. There is one problem over here though. We have learned that when you create a class, you instantiate the class, a constructor initializes its properties, right? Whose property is that red one in the middle? No one's. Everyone's. Who's gonna initialize it? The answer is no one. When you create actually a static, if you actually create a static attribute, it could be a static object too, it doesn't make any difference. It could be like I had a container and container had, if I had an employee had a name object in it, that the name object has a first name. If that one is static, then it's the same thing, that object becomes shared between. It doesn't have to be a primitive type. Appreciate that. Now, I have to actually create and initialize that outside of the class because it is something separate. So what I need to do at the right after the class, wherever I want, in the C++ part of the class that is being created, I will actually write integer container, and I'll create that C and T thing. So I'm essentially creating it and then initializing it to 0, or whatever number you want. So this line at 11 actually creates and initializes it. And it's exactly like a global variable, right? We said global variables are static, right? So no magic, this is static between them. But the good thing about it is that the scope of this is container, which means no one has access to this other than container. If it's a private property of a container, it's private, no one can access it but the container. We good down to this point? Okay? Now, next part is that now you can actually use this for praying proofs and stuff. So I can actually have something like container int value, and I don't need that drawing anymore. So I can have container value and set the m value to the value that we have, okay? And then inside the constructor, I can say mcnt plus plus. So essentially each time the object is created, the counter will be added by 1. So I can count and see how many objects out of the container is created. And to make sure everything is fine and dandy, what I can do is to actually create a destructor. And in that destructor, I can say MCNT minus minus. So creation and destruction will actually keep count of how many things I have. We okay with this? What's wrong with this code? People at home, you know you can talk too, right? What's wrong with this code? What's wrong with this code? Anyone? The destructor is not virtual. The destructor is always virtual, always. These things should be a red flag when you need to always remember that. Destructors are always virtual, never ever. No, like that, okay? Now, we can create another type of static too. We call a static method. Now, static method is a shared method between all the instances of the class. So, for example, I can do actually something like this. I can say over here static int number of objects. And sure. No, actually, why do I do that? I don't know. Sorry, we can't. And I write MCNT, return MCNT. So why static? What's the difference? I could have made it a method, right? A method can be called and it can access the CNT. Why did I make it static? Again, remember what I told you about the names that other languages give to these type of things. They call these type of attributes class variables, which means they belong to the class, not the object. And the static method is the same. It's a class method, not the object method. So if I instantiate, so you can literally call that method without even instantiating. So I can actually say cout number of container objects, and say over here container number of objects. And as you see, it's actually available in the IntelliSense. It tells you have a method that you can actually call. Okay? You don't need to instantiate it. Obviously, when I create a class, a container, if I say container C, whatever, I can say there's no problem with that. You can use the object to call a class container. There's no problem with that. Remember, the relationship is many to one. Now, which brings us to this. Take a look. So now I have a method. And that method is accessible to all as well. Are we okay with this? That brings us to this. What about the value I had in here? This is the attribute value, right? You follow this? Now, if you're standing in here and I tell you where is number of objects, you can show it, right? If I stand in, I say here, people at home don't hear from me. Let's make it better. So in here, I'm going to do something like this. If I'm in object number 2, I can see the MCNT. If I'm in object number 1, I can see number of objects method, right? But if I'm sitting at number of objects, I'm standing at number of objects, the square in the middle, and I tell you container class, which one are you going to show me? You can't, because you have 5 different ones around you. That's why static methods cannot access objects. They can only access the class variables. Remember, this is a one-to-many relationship, which means many can see the one, but one cannot decide which of the many. You follow? So because of that fact, you cannot access static property, you cannot access non-static property in a static method. So essentially, what I mean is, I can't say over here, can't do that. It doesn't know which one. You okay? Static methods are also used to create singleton objects. What is a singleton? A singleton object is an object that has only one instance. So what you can do, you can create a static you can make the constructor private. You can create a static method with a counter. And inside that static method, you can instantiate the object and return it out and add one to the counter. If the second one they call it, the counter is added by 1, you don't create anyone. Therefore, you can have only one object, like cout, like cin. You cannot create 2 instances of, you can actually, cout has many differences, c error, c stuff, but cin I think is only one. So you can, anyways, you can create singletons with this, okay? I'm not gonna go through it, but just be aware of it. So if they tell you, create a class with only one object out that only can be instantiated as 1, then you create an instantiated object. Should I do it? Nah, forget it. Just, you know that, right? So this one is static methods. Static members. Static member vars. Static attributes and methods. The heck with it, let me do that too. So what I was saying was this. Nah, I'm not going to do it. Then we have to go. You need some smart stuff that I don't want to do now. Forget about it. Yeah, forget about it. I'm sorry. I'm so sorry. For some reason, it goes off mute. My apologies, my apologies, my apologies, my apologies. My apologies. I keep, for some reason it. All right, so that's that. Okay, so let's see what else. Next topic. Size of stuff. We didn't talk about size of in this class, did we? We didn't. The reason that I keep asking is that it's very awkward because the other class has a Monday and today it's their lab and yours is the lecture, and so you're kind of 1 week, not 1 week, but I get confused did I talk about this already? So I have to go back and take a look at your notes, which I did. Anyways, using namespace. Okay, so this is what I wanted to talk about. It's quicker if I did this. Also, in the other class, I asked them if you want me to review pointers as I teach it for people who don't know what pointers are. Do you want that or not? So around 80% said yes. So we had a quick lecture of what pointers are. A clear understanding of a pointer. Soon we're gonna get to smart pointers and stuff like that. So we need to know them. So I'm gonna ask that from you guys too, and people at home. First of all, somebody please say something so I know you can actually hear me. I'm not talking to myself.
We can hear you.
Fantastic. Okay. Now, what I want you to do, first of all, people over here, who want me to go through it like a 10, 15 minutes lecture on pointer as if you're IPC 144 people, and I want to tell you what pointers are. Raise hands. One person over here, good. So no one here. At home, how many people want to have a lecture on pointers and what pointers are and understand their concept? 10 minutes lecture. Raise hand. You have to click on raise. Only 3 people. All right, watch the video of the other class. All right. We don't want it, we don't want it. Okay. That's that. Let's talk about aggregate initialization. You've done it, you've seen it in OOP345NDD. I'm gonna go through over here to go through it quickly over here. So curly brackets in front of anything is essentially at the moment of creation only. You cannot set something with. So if I want to set, for example, an integer to 0, you do this in front of it. That means 0. It's the same thing as equals. It's the same thing as, okay? Which kind of say why. Just the first one is the best. Because you don't need to know what is the default thing. It's going to default it anyway. Anything you want to initialize, just put empty curly brackets in front of it and it gets initialized. I strongly suggest when you create a class, put that in front of every single variable, every single attribute that can be defaulted, okay? And it works for any type of construct. So you can actually set up, as you saw in the container when I created. This is the one we have done, right? Yeah. So as you see, I actually initialized mValue like that. You can put parentheses over there, but curly bracket is the newest thing, the latest thing that you can do. So instead of writing parentheses instead of mValue to initialize it, I put curly bracket. If it's an array, you can actually initialize arrays like that very easily. If you have a constructor that accepts 3 arguments, you can use curly brackets instead of that. So if if I have a class, any type of class, let's say class foo over here, and it has if I have something like this, you can simply initialize that foo like foo f, and you do like this. So you write 1, 1.2, and A, B, C, D. It's the same thing as calling the constructor. So get used to that syntax and use it for anything you have, okay? So f is not an array. I'm just calling its constructor. Are we okay? So that's that. I'm just gonna add that over here. So initialization. Next thing we need to know is sizeof. The common mistake that everybody, people who actually get sizeof, they do something like this. They write character name, I don't know, like that. And then they say, so when I run this program, what it tells about name is what? 7, right? Are we okay with this? But that sizeof has nothing to do with string length. Don't be mistaken, okay? It literally tells you what that array is occupying in memory. It's not, my name has 6 characters, it's actually told you 7, which means if I have something like this, and I show the size of D, then the outcome is going to be obviously 80, because 80 characters is the space that, 80 bytes is the space that that thing is taking. Are we okay down to this point? Next thing, if I have over here foo that accepts a character name like that, and I have void foo that accepts a double like that, and I put these things over there. So name goes over there, and B goes over here. And I call the foo functions with name over here passed, and with D over here passed it out. The outcome is not what you expect at all. The reason is that, what is the outcome? 8 and 8. Can anybody tell me why?
Narrowing.
Pardon me?
Narrowing.
What does it mean?
I mean, promotion and narrowing.
No. Not, nice try, but no, that's not it.
Is it a pointer?
Yeah. So the only place you can actually get the size of an array somehow is in the same scope. You go out of the scope, you don't have an array anymore. That's why you should have accepted the pointers thinking that I wanted to do, and you said no, okay? So When you go to a function, it's actually a pointer pointing to that thing. So when you are saying, give me the size of D, it gives you the size of D, which is a pointer, which is 8 bytes. It doesn't matter what you're pointing to, a character or a double. It's 10 bytes. It's 8 bytes. Are we okay with this? Okay, so sizeof literally gives you the size of what you have in there. So essentially, in here is going to be and in here it's going to be which is essentially the same thing. Are we okay with this? All right. I'm filling the blanks, people, very quickly. Okay, so that's 0.3 sizeof. But it's not as simple as that. Sizeof really becomes complicated. Now, say I have this. I have a structure, I have a character, and double and an integer. Okay, so what is the size of this structure? So if I actually say sizeof in here, what's going to get printed? Oh. Anybody can have a guess? People at home, are you awake? Anyone? Anybody? Character is 1 byte, double is 8, and integer is 4. 8 plus 4, 12, plus 1, 13. Okay? $24. Which brings us to alignment. Understand what is alignment. Computer has a weird way of finding variables in memory. When a variable, when the type of a variable is 4 bytes, the compiler can only put it in an address that is divisible by 4. So an integer, if it's 4 bytes, it can sit at address 0, address 4, 8, 12, 16. You cannot have an integer sitting in address 5. Compiler, like, the computer cannot find it. It doesn't make sense for it. So essentially, when you put an integer in an address, it actually really say, I want to have an integer. It's as if it counts it from the beginning and sees where it sits. We go down to this point. Okay. So the first thing that I'm putting over there is a character, correct? So it's a character, fine. It puts 1. So when it's aligning it in memory, character will sit on address 0. Let's assume that one. Then the next address available is 1. Can a double that is 8 bytes sit at 1? No. 2, no. 3. It keeps going until it gets to 8. 7 bytes are wasted. It puts the double at the address 8, and it keeps going. So the next available address becomes 16, right? And 4 can sit on 16 because it's divisible by, so we're good. So 8 plus 8, 16 plus 4, 20. What the heck is that for? So if then the compiler says, fine, if I make this 24 byte, what if you want to create a structure T1 array, which means I want to put another structure after it. If I put the second structure after T1, the next available address is 20, correct? 1 can sit on 20, beautiful. And then 21, 2, 3 goes to, what is the next one? 28. Is 28 divisible by 8? No. So it cannot create an array out of it. Because of that, not only it has to align before, but it has to align after. Because a double should always sit at the address 8. Therefore, T1, when it creates the 1, then double sits at 8, then integer sits at 4. To make it possible for the next one to sit at address 8, it adds 4 extra spaces after 4, as after the integer. That's why you get the size 20, 24. So now take a look. If I create the second one over here, people at home, are we good? Can you show me a thumb up or something that I know you're alive? Say something. Yeah, there we go. One person is there, good, and the rest are napping. All right. So if I create something like this, it's the same exact number of things, right? A double, an integer, and a character. But take a look at the size now.